right, hello everybody, and welcome to episode 12 of Technically Speaking. I'm super excited for this particular episode as we kind of wrap up the season, the initial season of Technically Speaking. I'll talk a little bit about, at the end of today's session, about what we're going to do with season 2. We've already got plans in the works for where we're going to go with Technically Speaking, especially given just the strength of attendance that we've had this year. I want to start this session off by thanking a number of the folks as I look through the attendee list that have been on virtually all of the episodes. There's actually been 13 if you include the pilot that we started with exactly a year ago today. So thank you for that, and thank you for the attendance and helping us continue the Technically Speaking track. Really looking forward to where we're going to go with this next year. So with that, let's go ahead and kick things off. I'd like to start just again real quickly with the introduction. My name is Brandon Burton, for those that are joining for the first time, and I am the Senior Principal of Industry Relations here at CoreLogic. Also the chair of the ANSI and IICRC standards. And I bring a lot of Technically Speaking from really my perspective as the IICRC standards chair, really focusing on best practice and industry standard of care to really help all of us focus on what I feel at least will help us raise the bar in the industry and the level of professionalism in water damage mitigation, and moving into next year into restoration at large. We're really going to expand our topics as we move into next year. The focus for today, however, is going to remain on water damage and really recapping where we've gone this year and really extracting some of the best secrets that we talked about this year. A couple of housekeeping notes before we get started. Remember that we don't use the chat feature here in Technically Speaking. We use the Q&A feature. So if you're new to Zoom or not familiar, there should be a little menu bar, and in that menu bar, there's a Q&A option. Anywhere throughout the presentation today, if you've got a question that you would like me to address, just type the question into the Q&A. Doesn't even have to be on topic with what we're covering today. Anything at all under the sun as it relates to water damage mitigation, drop that question into the chat, or the Q&A rather, and I'll make sure at the end of today's session that we go through that Q&A. For anybody who doesn't watch this live, today we're live, but if you don't watch this live, you don't have access to the Q&A. So that's kind of the added benefit of being here with us live, is having access to that Q&A. So with that, let's go ahead and roll forward and get started with Technically Speaking, the best kept secret. So here's kind of the agenda for today. I'm going to go through, I went through all of the episodes throughout the calendar year and even the pilot episode, and I extracted from that what I felt were the 7 best secrets, the most impactful, the most meaningful, and the most critical technical aspects of what we addressed this year. I'm going to recap all 7 of those, put a little bit of a new spin on some of them, and really give you what I feel are the most critical to implement takeaways from those secrets. So should be a great season recap here as we go through. Again, as I go through this, if you have any questions about what I'm covering today, any questions even outside of what I'm covering, feel free to drop those into the Q&A and we'll address those. So with that, let's start with number 1. The number 1 best kept secret that I want to really emphasize here today, that I feel is not only one of the most basic to water damage mitigation, but what I have seen really lifts the curtain for a lot of folks in this industry. I've been training in this industry for about 25 years, somewhere in that neighborhood. Haven't done the math in a while, but I think it's somewhere around there. And as I go through courses and talk about psychrometrics or moisture and monitoring, as I go through those types of topics, the one thing that I've seen really lift the veil and have people raise their eyebrows and go, I finally get it, is this first secret. That first secret is something I call measure twice. All right. Let me explain what I mean by that. There's a lot to learn in this industry, especially on the technical side. You get into something like psychrometrics in particular, and you're talking about things like vapor pressure and vapor pressure differential and grains and dew points and all of this stuff. You get into moisture monitoring, and we talk about moisture content versus wood moisture equivalency, and all these really fancy terms that can really derail kind of the average way of thinking about a project. And it really doesn't need to be that complicated. It really doesn't. When you understand that all that really matters with virtually all of these things that we measure, or metrics or numbers, as it relates to not only water damage, but really anything in life for that matter, you've got to measure twice. It's not about a single point of measurement. It's about taking multiple points of measurement and making comparison. And I'm going to give you just a few analogies into this, but let me start with one that has nothing to do with water damage, right? If I was to analyze the financial health of an organization or even an individual, right, understanding the balance in a bank account at one point in time tells me nothing about the financial health. You could have $1 million, right? That doesn't really matter. What matters is, what is that balance doing over time? Is that balance growing or is that balance shrinking, right? That's what's most important about that financial health. It's the same in water damage. It doesn't matter that there are 37 grains per pound in the air in a living room when you're drying a home. That doesn't matter. 7 thousandths of a pound of water for every pound of air within the space. Sounds really fancy. Doesn't tell me anything. What I need to understand is another point of measurement to which I can make a comparison. That could be a point of measurement over time. It could be a point of measurement to another area. It could be a point of measurement from the air coming out of a dehumidifier. They're all comparisons. And I know that I'm using an example that's probably well understood as we talk about grains per pound, but it doesn't matter which of these metrics we're talking about. They're all points of comparison. So let's kind of dig a little bit deeper here and get into some examples. First example I want to give you is the one that I think doesn't get used nearly enough. And that's taking not one measurement in a drying chamber or an affected area, but two measurements in the drying chamber or affected area. I mean, what does it tell you if you just take a single hygrometer reading in the middle of an area that you're drying that comprises 5 or 6 or 7 rooms? If I just take a single measurement in the middle of one of those rooms, that doesn't tell me how healthy my drying system is. It tells me how that one little tiny microscopic sample of air is. Now, if I take that measurement and go to the extreme opposite end of my drying chamber and take another measurement and compare the two, if they are identical or virtually identical, now I know a lot. I know that we're mixing the air very well in the chamber. We're distributing the effect of our dehumidification, our temperature control, our humidity control. We're distributing that well throughout the chamber. If they're significantly different, then I know something's failing. At a minimum, my air movement is failing, right? At a minimum, we are not circulating the air within that space effectively. And again, this just comes from a single understanding that we measure twice, right? A point of comparison. Now, we could go through this example a number of different ways. Another quick way that I want to go through this example is to talk about it over time. Here we've got a measurement of 41 grains per pound, the amount of moisture in the air on a project at a particular given point in time. Now, again, that could be good, that could be bad, right? I really don't understand if I've only got a single point in measurement. What I need is a second point in time to make that comparison. Now, again, and I'll dig into this very, very deeply when we get into another secret here in just a little bit, but consistency here is key. If I'm making comparisons over time, then I need to be making the measurement in exactly the same way. I need to be using the same hygrometer in the same location, at the same height above the floor, for example. I can't make changes to the method of measurement if I'm making this comparison. But if I do this in the same way, now I know something quite meaningful. If I had 41 grains per pound, and now I have 78 grains per pound in my air, that's the actual water content, then the actual water is increasing over time. Is that good? Is that bad? Well, it depends on what I've just done to the project. If I've done nothing and the water is increasing over time, that's bad, right? That means that there's a rate of evaporation that is not in control. It is greater than my humidity control rate. Now, if I've just made an adjustment and I expected to increase some humidity because of that adjustment, that could be a different story. But at least now I know that humidity is increasing over time. And I know that because I measured not once, but twice, right? So that's the first really critical industry secret. We started with that industry secret all the way back in the pilot episode. And the reason we started with that 12 months ago is because, to me, this is one of the most critical concepts, especially for those of you that work a lot with training technicians as they come into this industry. If there's one thing that they've really got to hold on to and understand is don't get lost in the details about the numbers. Don't get lost in the details. The first and most basic thing that you need to understand is all of these measurements that we take, they're only important when there's a second measurement to compare them to. And we could make that argument about even the amount of moisture in building materials, right? Does it matter that the wall is 55? If all I told you is that the wall is 55, that's my moisture reading is 55. By itself, it doesn't mean anything, right? I need a couple of different points of comparison. Now, if I told you that with that same meter on that same setting in an unaffected area, the reading is 72, now we know that 55 is not a problem, right? That's a point of comparison. Same meter, same setting, known unaffected. We call that a dry standard, but that's a point of comparison. Or if I told you that yesterday, with the same meter on the same setting, the value was 130, right? Then today 55 means something, but it again only means something if we have the point of comparison. I think too often, and I know I'm really belaboring the point, but it's critical. I think too often we get wrapped up in the single number and we try to interpret the single number, and a single number by itself cannot be interpreted. So with that, we'll move on to secret number 2. As we move on to secret number 2, by the way, I want to thank Raphael and Andrew for already getting some questions posted into the Q&As. My quick reminder, as we're going through today, make sure that you get questions in the Q&A. Raphael, by the way, I'll answer yours here in step. There is an ability to access the previous episodes. I'll show you that on one of the last slides today. I'll show you exactly where to go. But all of the episodes, for Technically Speaking, have been recorded and they are available to watch. So I'll show you where to do that at the end of the presentation today. Andrew, your question's a bit more in depth. We'll hit that at the end of the presentation today. All right, so with that, let's move into secret number 2. So here in secret number 2, I'm going to talk about a concept, again, that I feel is a really tightly kept industry secret. And by that, what I mean is it's a vastly important process that rarely, if ever, gets used. And to me, just being the kind of the technical geek that I am as it relates to water damage, I don't understand why this isn't done more. But for those that do it, I guarantee you they are drying buildings far more effectively than those that are not. In addition to that, they're also justifying their decisions more effectively. They have a lot more evidence for the reason why they're doing what they've done. That secret is the surface matters. Okay. Now, what do I mean by the surface matters? Well, here's the mistake that a lot of water damage mitigation contractors make. They do exactly what has been prescribed and follow it to the letter of the law. They walk into a room with a thermal hygrometer and they take their atmospheric readings. Atmospheric meaning your air readings, temperatures, humidities, etc. And they stand in the middle of a room and they take that reading and they find out they've got 85 degrees and 23% relative humidity. They even convert that into grains per pound, right? Or the meter does it for them. And they find out they've got 41 grains. Wonderful. Congratulations. First of all, rule number 1 or secret number 1 still hasn't been done, right? I need a point of comparison, right? What was it yesterday? All right. What is it in the next room? What is it outside? These are all comparisons I could make, but there's another comparison that really needs to be made that often isn't. And that is what's happening down at the surface. Think about this for a moment. What air is actually impacting that surface that you're trying to dry, or the material beneath that surface? Is it the air 3 feet above the floor or 2 feet above the floor? It's the air in contact with the floor. That's the air that's doing the work. So why aren't we checking it, right? It's irrelevant, quite honestly, that you have 41 grains per pound 3 feet above the floor. It's an important measurement, and I'm going to use that to make comparison to other areas and other rooms to find out how I'm managing my chamber. But that's not the measurement that's going to tell me how effectively I am impacting the moisture in the material itself. Now, this could be a vertical surface, it could be a horizontal surface, but it's the air at the surface. It's the air in contact with the material that is influencing the material. That's the air that actually matters. Now, what do I do about it, right? If I observe that my conditions 3 feet above a surface and at the surface are the same, wonderful, right? That's a very, very strong indicator that you've installed your drying system appropriately. But when there is a deficit, it comes right back to the same analogy that we talked about earlier. It means that air movement has not been installed appropriately. If your air movers are installed effectively, then the condition above the surface and at the surface will be the same or virtually the same. If they are significantly different, there is not enough airflow along that surface. Document it, record it, adjust it, add if you need to, and your reason for adding is this exact rating that we just discussed. The surface is critical because that's where drying actually happens. That's where thermodynamics is occurring. That's where equilibrium is happening. That's where vapor pressures are impacting the moisture within the material. It's not the vapor pressure up here at chest height. It's the vapor pressure down at your feet, okay? So the surface matters. Technical secret number 3. So number 3 is to me at least, is for those that have understood the basics. You're effectively drying structures, but you're still running into challenges where you hit a job on day 2, you observe something's wrong, you make an adjustment, you come back on day 3, something's still wrong, you come back on day 4, something's still wrong, and you're just getting frustrated because even though you're taking the readings, you're making the comparisons, you're making good progress overall, you just know you could do better, right? To me, this is what secret number 3 addresses. Is we have a habit, if you will, as human beings to solve symptoms instead of problems, okay? And this is something we got into in episodes 1 and 2 pretty deeply. But when you're diagnosing what's occurring in a water damage mitigation project, you really have to purposefully and intentionally prevent yourself from solving symptoms and focus on solving problems. And I'm going to give you a couple of tips on how to do this, but first let's go through an example. So remember that example we looked at just a moment ago, measure twice, make a point of comparison. Well, let's dig a little bit deeper into that one. So we took a measurement at one point in time on a job, and we find out we've got 41 grains per pound inside the affected area. Sometime later, right, and it could be a day later, it could be hours later, we find that our grains are now 78 grains per pound. They're increasing. All right. You haven't done anything where you would have expected them to increase. So these are increasing purely because the rate of evaporation, so the rate water is leaving building materials, is occurring faster or at a greater rate than your humidity control, most commonly dehumidification, but humidity control. So you're not pulling water out of the air as fast as it's being added, to put it in really simple terms. The knee-jerk reaction that most of us have to this is that, well, that's an easy fix. I need to add more dehumidification. Well, think about this for just a moment. The symptom is the humidity increasing over time. Your assumption is that because you don't have enough dehumidification. That's an assumption. And what you're doing at that point is you're treating the headache without finding out the reason why you've got a headache, right? You're just taking aspirin for the headache. In other words, you're masking the symptom. In order to understand truly what the problem is, you need to ask yourself why, right? And the model that I've always used, and it actually works really effectively even with my kids, is ask why a minimum of 5 times. There's actually a really good book on the concept called The 5 Whys, if you're into reading and just kind of overall human potential growth. But ask the question why a minimum of 5 times, okay? And you know, if you may get to the solution and the core problem sooner than that, but if you can build a habit of doing that, trust me, you're going to be far more effective. So let's ask the question why. Why is my rate of evaporation exceeding my rate of dehumidification? And there are lots of potential answers to that question. For example, let's dig a little bit deeper into the dehumidification. Let's just talk about the dehumidifiers not providing the amount of humidity control you expected, right? You did math to figure out how much you needed. You figured out your class of water, you figured out your volume of space, You did a little bit of math and you found out that you needed a certain number of pints of dehumidification. So unless something is abnormal, that should be effective. It should be effective at controlling the humidity. So why isn't? Let's take a closer look at that dehumidifier. And one of the very first things that I'm going to look at is, what does my hour meter tell me? Did that dehumidifier actually run the entire time between my first and second reading? Or did the property owner turn off the equipment the moment I left, right? If that's the problem, the hour meter is going to tell me, and that's going to get me to the root of the problem. Adding dehumidifiers will not fix that, right? If I go the knee-jerk reaction of just adding dehumidifiers, all I'm doing is adding more power buttons for them to hit when I leave, right? I've got to get to the root of the problem. Let's go through another example. Let's say that the reason for the problem had nothing to do with the dehumidifier. It's operating fine. It ran the whole time. I even monitor my grain depression on it and find out that it's actually performing quite well. So maybe it's because there's more evaporation than I anticipated. Did you effectively find the entire affected area? Or was there a recurrence of the water source? Right? So let's look closer at the surface area at which evaporation is coming from, that total area contributing to moisture. If it was a reoccurrence of the water source or I missed an affected area, again, adding a dehu is not going to fix that. It's just going to mask the problem. And it could be that the dehumidifier is just not performing as it should, right? And that's why we get into things like grain depression, right? And analyzing the performance of our dehumidifiers. Grain depression, by the way, an entirely separate discussion that we're going to dig into very deeply on an episode next year, because it's wrought with problems if it's not something we fully understand. Having said that, let's move forward. So the example here is that we need to understand the root of the problem. If we don't understand the root and we just apply a fix to the symptom, you're just masking the problem. And this is the reason why we apply a fix like adding a dehumidifier, but then we come back the next day and find out after another 24 hours have transpired, that didn't fix the problem. It just covered the symptom, right? And that's the reason why we get into multiple days of applying solutions to symptoms and then finally just pulling our hair out and saying, you know what, just get rid of the material. And we wasted a lot of time and energy to get to that conclusion. All right. So that is industry secret number 3. Industry secret number 4. So kind of growing in complexity here and growing in kind of the maturity of the technical level. The next secret that I want to share with you is understanding the differences in mindset between how we look at data on a job. There are different reasons why you're going to go to a project and collect information about that project. And if we don't understand the different reasons for doing it, then our methods will be wrong. In other words, inspection and monitoring are not the same. All right. And often we go into one of these two processes thinking that they're identical. And if we do that, we're going to do them wrong. Okay. We're going to do them very, very wrong. Inspection is a process where we are trying to define the exact condition at a single point in time that is highly detailed. I want to understand where the water originated. I want to understand precisely how far it is migrated. I want to know every building assembly and component that are affected. And assembly and component being two entirely different things, right? Assembly is a wall. Component is the 2x4 in the wall, the insulation, the gypsum wallboard. Those are components. I need to understand in my inspection process all the above, right? Highly, highly detailed. Going to use an instrument in lots and lots of different locations until I find the absolute edge of that migration. And not only am I going to document what I found that was affected, I'm going to document what I found that wasn't affected. Let me stand on that soapbox for just a quick second. I'm going to track water migration in a given direction, and I'm going to continue looking until I find something that isn't wet. And then I'm going to document everything that I checked. All right. Think about it for a moment. Why did you check the subfloor beneath the cabinets in the kitchen? You checked them because the floor adjacent to that was affected. In other words, it was reasonable to assume that the floor beneath the cabinets was also wet. So if you discover that the floor beneath the cabinets is not wet, great, wonderful. That's outside of my migration, but document that you checked it because it was reasonable to assume that it was wet. Does that make sense? So when somebody pulls the cabinets in the future for some other purpose and finds water damage beneath the cabinets and they go, oh, That's right. There was a water damage in here a couple of years ago. ABC Cleaning and Restoration, sorry if there's anybody with that company name, was here handling the water mitigation project. I wonder if that's what caused this, and they didn't dry it, right? And they go to your documentation, they find wet across the floor, no readings under the cabinet. Guess who just bought the damage, right? So I'm going to say that whole thing one more time, and they'll step off the soapbox. We are going to inspect with high detail in every direction until we find the edge. You know you found the edge because you find something unaffected. And when you find that unaffected, document it. Stop, you don't have to keep going further, but document what you found that was unaffected. That's your evidence that you found the edge, okay? So inspection versus monitoring, back on point here. So inspection is highly detailed, single point in time, understanding precisely at the component level what is affected. Monitoring, on the other hand, is something entirely different. Monitoring is not detailed. Monitoring is consistent. All right. If you monitor at the same level of detail that you inspect, you'll never get done with a monitoring trip. It just won't happen. Right. So we identify locations within what has been determined affected, and then we become precise, not detailed, but precise. We lock down the meter, the make, the model, the setting, the location, even the way we're holding the meter. All of that gets locked down, and we do that the same way at different time intervals to determine progress. It's consistency. So inspection is detail. You put on your detail hat, be highly, highly detailed. Write down lots of information. Monitoring, on the other hand, we're going to be very precise. We're going to have a very fixed method, and we're going to follow that method precisely. Okay, so let's dig in just a little bit deeper to these examples for a moment. In inspection, again, if this was my affected area, I'm going to end up having measurements in multiple locations. Lots of instrument types, lots of components and assemblies that need to be validated to determine if they're affected. But once I've made that determination, then we're going to identify monitoring locations. And monitoring locations are going to be highly consistent, right? So within that affected area, I'm going to track the change in moisture level. Will I lock down the meter make and model, the meter setting, the meter scale, location, depth, attachments, even things like angle and orientation. So another quick soapbox to jump on here before we move off of this point and into the next secret. This is an area in your organization that you should focus on in those Monday training sessions that you have once a week with your technical staff. And here's the way that I would do it. If I were to make a suggestion, if I was going to be your water division manager and I was setting up, kind of how we're going to sharpen the saw, to steal from Stephen Covey for a second, on how we do our monitoring, here's what I would do. Once every week, I would pick one material and I pick one technician, and I would have them do a quick 5-minute presentation to the rest of your staff on precisely how we measure that material on a mitigation project. This is the way we do it. We use this meter on this setting and this scale and this way, and this is how we hold it. This is the attachment we use. We do it exactly this way, right? And then I would have just a little log, a little SOP, or just a list of materials that defines that, okay? Here's the challenge you're gonna face though. You've got, let's say, 7 technicians. Those 7 technicians all have their own opinions on the best way to monitor a wall plate. Okay, a 2x4 wall plate behind a sheet of drywall behind a baseboard. We all have our own opinion on the best way to do that. All right, and none of those opinions are wrong, quite frankly. There are lots of different ways to monitor that 2x4 wall plate. The problem is there's only one right way to do it, and that's the same way that it was done yesterday. And this is a realization you've got to bring your entire technical staff to. And that's why you got to focus on it. You got to really focus on it. You got to get everybody to agree that even though there's 1,000 right ways to do it, we all know there's one wrong way to do it. And that's different than it was done on day one. For that reason, we have to lock down one method so that Bob, Sue, Joe, and Will, or whoever else is going to be monitoring a job, that they all do it in exactly the same way. Okay, it's a really critical point of emphasis for your organization. This is the reason, by the way, that you'll end up with job documentation where, day 1 a material is this wet, and then day 2 it's this wet, then day 3 it goes up again, then day 4 it goes down again, then day 5 it goes back up again, because it was Bob, Sue, Bob, Sue, Bob, Sue, right? And all of a sudden we've got 2 different methods being integrated into the same documentation. absolutely meaningless documentation, right? If anything, it's just going to create anxiety and incorrect solutions or problems that we're trying to apply to the project. So it's really critical that we hone in on that and do it in exactly the same way. All right. So with that, let's move into technical secret number 5. So technical secret number 5 relates to the fact that no job is ever the same. In fact, the same job is not the same the next day. And that's really where this secret kind of hones in. It's critical that we understand that a job is continuously changing. Think about this for a second. The last water damage project that you looked at, I want you to kind of visualize that project for a minute and what it looked like day one. How much water was there after you finish your initial emergency response and extraction and what have you, the amount of moisture that was present in that space, and therefore, the amount of equipment that you needed, the type of equipment you needed, how that equipment was placed, right? And just kind of visualize that for a second. 24 hours later, the job was different. It was a different amount of moisture, different type of moisture, all right? Would it be fair to assume then that the equipment needs were also different, right? Did it need the same air movers in the same place with the same dehumidification scheme? And here's another way I'm going to ask that. If you responded to that job on the second day, and the first day never existed, right? All that work that was done the first day just magically was done before you ever got there. Would you have placed that equipment the same way? Would you have addressed the drying approach the same way? Probably not. All right. And how we get to this and understand this is the next secret. The next secret is that HAT has an element of time. And what do we mean by HAT? HAT means humidity, airflow, and temperature, right? These are the 3 elements, if you will, that we manipulate to facilitate the drying process on a project. We need a certain amount of humidity control, air movement as a transportation system, temperature as a form of understanding the energy that's present to drive evaporation. These are the 3 drying pie, if you will. And normally we look at this as a circle, right? With 3 pieces in the circle and each piece being equal, which is a misnomer because they're not equal, right? Which one's most important? Which one's least important? Which one needs to be higher or lower? That changes with time. And that's where this next secret really starts to show its colors. So through the drying project, the elements of HAT vary in their priority. Initially, we deal with surface water, right? Water that if I were to touch the surface, my hand would get damp. With this, airflow is by far the most important element of HAT. And the reason that it is because airflow directly adds energy to the moisture. Just the movement of air across a body of water is going to add energy to that body of water. It's going to excite molecules and support the evaporation process. Humidity and temperature are important just to keep up, right? At that point, you're drinking from a fire hose. In fact, this is a point in time when grains will typically increase on us and spike on us while that surface moisture is present. Hopefully, by the way, this is monitored in minutes to an hour, this humidity spike, not hours to a day. If your humidity spikes in surface water are lasting into the second day, you are not extracting well enough, all right? You are leaving way too much free bulk water on the project. This should be measured in minutes, if not hours at the very, very most. The second stage we move into is something called the free water stage. And the free water stage is liquid water that is held in all of the air spaces within the material. So in the pores and cavities, for example. This water also evaporates very readily because it's still a liquid form, but the evaporation rate begins to fall off just a little bit. Air movement is still the most influential. However, lower humidities and warmer temperatures begin to become more important because lower humidity is used to draw the moisture out of those pores in a vapor state. Temperature is going to directly impact the moisture in the building material or the assembly, right? Air movement's no longer in direct contact. The only reason air movement is still slightly ahead is the most important is because your evaporation rates are still high enough that you need to transport that evaporating moisture away at a pretty high rate, okay? As we move into the final stage, this is commonly referred to as the falling drying rate stage. We move into bound water, and this is an entirely different kind of water. And you'll notice this because your humidities in your structure will finally just take a little bit of a drop, right? You've been kind of slowly working your humidities down, and all of a sudden they take a bit of a drop. And the reason that they do is because your evaporation rate just took a nosedive, right? The amount of moisture leaving building materials has significantly tailed off, and the amount of humidity control you have is now going to result in a much lower humidity within the space. You'll also notice that because your moisture content drying rates will start to slow down, right? Because again, evaporation is slowing down. Last but not least, you'll also notice this if you're using a wood calibrated moisture meter on wood-based materials, when your moisture levels are at approximately 30. That's referred to as the fiber saturation point in wood. And once you drop below 30 and you start getting down into the 20s, you're dealing with water that is bonded to the material itself. It's no longer water molecule bonded to water molecule as a liquid. It's water molecule bonded to something in the wood, right? It's bound, it's chemically held. This is when all of a sudden humidity and temperature become your priority. Air movement is almost useless. Almost, not quite, almost. And what I mean by almost is all you really need at this point is enough air movement to create a room-wide circulation. I would challenge you to really test this out the next time you're on a water damage mitigation project and you get into those falling drying rates. Play around with your air movers a little bit. Turn a couple of them off and measure your humidity down near the surface of building materials that are only measuring it, 20, 22, 23 on a wood scale. And find out if by turning off an air mover, if the humidity down at the surface on that material changes at all. If it doesn't change at all, that air mover, it wasn't doing anything, right? All you really need is a few feet per minute in most cases, maybe 10, 20, 30 feet per minute, to ensure that you're removing that water as it evaporates at a very, very slow rate. And for a typical room size, believe it or not, a single air mover is typically going to check that box. Depends on the obstructions, it depends on the number of contents in the room, so it depends on a lot of variables. But generally speaking, if it's a box that measures 10 by 10, a single air mover, it's probably going to be ample. In fact, it's probably 5 times more that you need, but that's the size that rooms are, and we use the air movers we use. So what becomes critical at that point is really about making sure that the vapor pressure at the surface is low, right? And that's going to be your humidity. It's going to be ensuring that the material temperature is warm, okay? We talked about this in an episode, I think episode 8 or 9. We talked about the temperature of a material can be set using dew point. The temperature of the material should be 20 degrees warmer than the dew point of the air in the room. And if you've got that dew point at 20 degrees above the dew point of your air in your room, you've got a low vapor pressure, you've got at least an air mover in that room creating circulation, you've got what you need to address bound water, okay? All right, so with that, let's move on to best kept secret number 6. We've got 2 left. This is, again, a quick reminder, if you haven't yet, make sure you're dropping questions into the Q&A. I've got a couple of good ones that are waiting for us. So thank you, Andrew. Thank you, Josh. So we'll get to those here in just a bit. Let's move in now to secret number 6. So in secret number 6, I want to talk a little bit about some of the more advanced concepts in structural drawing. Commonly, we overlook what our eyes don't see, all right? And believe it or not, in the average water damage mitigation project, more than 30 to 40% of what you're trying to dry surface-wise is not visible. In fact, in some cases, it could be even much higher than that, depending on the circumstances of that particular project, especially when you're dealing with things like hardwood floors, cabinetry, affected structures that come from one floor and migrate down to the next, where we have wall cavities and ceiling cavities. Many times we are dealing with wet surfaces that are beyond what is visible. And if it's beyond what's visible to my eye, if I can't lay my eyeballs on it, then your standard air mover is probably not addressing the wet surface. When surfaces are wet that are interstitial or hidden, oftentimes we need specialty drying systems. And specialty drying systems, if 30, 40% or more of the time, the surfaces I'm trying to dry are hidden or beyond sight, then 30 or 40% of the time, I should be doing something with air movement to get it into those hidden spaces. We don't see that happen nearly that often. So this is a very underutilized arsenal in the toolbox in water damage mitigation. The number one reservation I typically get when I share that is, well, what if I bring something like this in, I'm just bringing in another challenge that I have to explain in the invoicing side of things. And quite honestly, I don't think that's a valid reason not to do this, right? If it's the right thing to do, then do the right thing and keep doing the right thing until it feels right and everybody understands it's right. What you're missing if you're running into challenge is the documentation to support it. That's what's missing. And the way we capture that, I'm going to give you a couple of tips on this, but generally speaking, the way we capture that is to ensure that we have accurate documentation of what's actually affected and where those wet surfaces are, and then follow that up with accurate documentation of what these systems are doing for the mitigation process. So I'm not going to get in real high depth and detail into each of these. We've got a great episode on interstitial cavities where we dove real deep into these different systems, but I do want to give just a quick overview. When you select a specialty drying system to deal with these areas, you've got to understand that no two systems are the same, and they all have their very specific applications. That application comes from their balance between the volume of air that they produce and the pressure behind that flow. The reason those two are so important in concert is because every cavity you're trying to dry has a different mix of volume and resistance to flow. The greater the volume of that space, the greater the volume from the air mover in terms of the ability to impact surfaces. The tighter that space is, the more critical the pressure behind that air becomes to overcome that resistance. And every one of these specialty systems has a different balance between these. Ideally, we'd have an air mover that has really high volume and really high pressure. The problem is you need 230 volt power at 30 amps to run it, right? That's the reason why we don't have air movers like that. So in order to make power realistic, you've got to find the right technology that has the right balance between volume and pressure. And I've given a couple of examples here on the next slide of applications for these different blower types and where they fit well based on that pressure between volume and pressure. But to kind of study up on this, if you missed that episode, just go back and review the episode we did on interstitial cavities and voids, where I dive into a much greater depth and detail on each one of these systems. Where I do want to spend a couple of minutes, though, is talking about the justification side of it. So when I do this, and I use these types of systems, I think it's important to anticipate the questions that you're going to get when you do something different, right? If you do something on a project that isn't normal, that isn't expected, that's kind of out of the norm of what would be expected, then I think it's reasonable on us as contractors to provide the documentation that supports it. I think it's a very reasonable thing to do. So here's what I would suggest. First of all, document the fact that it is a wet surface. That should be in your documentation. You should have a moisture location for it. That moisture location should call out the specific component that's being monitored. You should be tracking the moisture in that component. So all of that is very, very important to just stand up the fact that it is affected. But here's the second thing that I want you to do that isn't done hardly at all, which is, in my mind, just as critical. Provide the documentation that shows the work the system is doing. And here's how you do that. Monitor for that space, that cavity, that void. Monitor the air going into that void and the air leaving that void. That's what that specialty system is doing. It's creating flow through that cavity. Monitor that flow. Track the amount of moisture going in and the amount of moisture coming out and the difference between the two. This is something that we call grain depression, right? In this case, maybe a grain rise, but it's the same difference, all right? Now, I'm going to analyze this a little bit deeper, and then I'm going to simplify it. If I know the exact amount of water by weight going into a space, it absorbs moisture on the way through, then I know the exact amount of moisture in that air as it returns to me, and we increase that water by a specific weight. Then as long as I know how often that's happening, then I can figure out how much total water we're removing. I could express it in any unit of measure I want to express it in. I'm going to choose to express it in pints per day because that's the common vernacular that we use in this industry. Dehumidifiers are sized in pints per day, right? So if I tell you that this system is drying this wall at a rate of 30 pints of water removal per day, that can kind of make sense, right? I can compare that to how big some different dehumidifiers are and how effective they are, et cetera, okay? So that's the way we're going to do that. The shorthand for this is the calculation you see at the top of the slide. Grain depression, which is the difference of grains going into the cavity versus the grains coming back out. And that cavity could be a wall, it could be a hardwood floor, it could be cabinets, it could be a whole building on an exhaust system. It doesn't matter. Grain difference multiplied by CFM. CFM stands for cubic feet per minute. So that's the volume of air at which we're getting that grain difference. That tells me my rate. Divided by a magic number, 71, equals pints per day. Now, if you want to know where the 71 comes from, it comes from the longhand math. You could do this calculation in about 20 steps if you wanted to, but we simplified it down to divide by 71. That's because we're taking grains per pound, which is 1/7,000th of a pound. That's what a grain is. We're taking the weight of a gallon. We're taking the number of pints in a gallon. We're taking cubic feet per minute, the number of minutes in an hour, and number of hours in a day, and how much air there is in a pound of air is 14 cubic feet. Trust me, it's all in there. That gets consolidated down to divide by 71. So we're saving you some math. Here's an example. So if we had air going into this cavity at 43 grains, we had it coming back out at 68 grains. The difference between those two is 25 grains. So are we picking up moisture on the way through? Absolutely. Does that number by itself tell me the system is working? Yes. But does it tell me how well it's working? Not really. Right? If somebody asks me, why did you install that inter-air drying system on a wall cavity? Is it really needed? And my answer to them is, well, I'm doing it because it's removing 25/7,000ths of a pound of water for every 14 cubic feet of air processed through the cavity. Crickets, right? And I expect that. That doesn't tell me a whole lot. Sounds impressive, sounds technical, doesn't really tell me much. If I take that number, multiply it by the CFM of the blower, which is about 100, then divide by 71, what we find is that we're removing 35 pints a day. Now let's rephrase that. Why are we using the inter-air drying system on the wall cavity? Because it's removing 35 pints of water per day from that assembly. Without this system, that water would not be removed at that rate. We'd be here far longer. Right? It's solid justification for the reason why that system exists. Your standard air movers are doing that for the surfaces that face the room. That's what they're doing for you on what faces the room. This air mover is doing that for the other drying chamber inside the wall cavity, which kind of leads me to the conclusion on this particular point. You've got to think about your drying chamber as the totality of all of these wet surfaces. The drying chamber doesn't end at the portion of the wall that's facing you. That's not where your drying chamber ends. Your drying chamber ends at the dry material outside of your water migration line. That's where your drying chamber ends. And if that's the exterior feeding, then so be it. That's where your drying chamber ends. The cavity has affected surfaces. It needs to be in your chamber. Air movement needs to circulate all of the air within your chamber. And that's what specialty drying systems are there for. Okay. All right. By the way, I'm seeing a couple more questions pop into the chat. Thank you for that. This is my last reminder to throw some more questions in. I've got a couple of good ones. We'll hit those right after secret number 7. So to kind of conclude things here in a recap on industry best kept secrets, I've got to finish with some psychrometry. For anybody who knows me and knows me well, you know I can't get through something like this without talking a little psychrometrics. So here's where I want to conclude. The last industry best kept secret is that the only reason you're using grains per pound for all of your monitoring is because that's the way we've done it since 1998, and it hasn't changed since. In reality, the most important metric that you're going to compare, psychrometrically speaking, would be dew point. Okay, for lots of different reasons. Go back and review the episode we did on dew point, and you'll get into lots of them, but there's one in particular that I want to recap. At a minimum, you need to understand the dew point of the air inside of your drying chamber. At what temperature, if I were to cool that air, would it achieve saturation or 100% relative humidity? Know that temperature and compare that to all of the temperatures around you. So let's take a look at the room here in the very upper left-hand corner of this diagram. It's 80 degrees, 40% relative humidity. It's got a dew point of 54 degrees Fahrenheit. What does that mean? It means that if that air is allowed to cool down to 54 degrees, that 40% relative humidity will not be 40% anymore. It'll be 100% relative humidity. Then ask yourself a question. Is there a risk, given this scenario, that that air is going to cool down anywhere near that dew point? Really simple answer, look outside. 36 degrees Fahrenheit. That is below the dew point of my air. So if that inside air gets anywhere near that outside air temperature, we're going to have problems. It won't be drying, it'll be condensation. We'll be going in the opposite direction. Where could that occur? Well, it could occur in a few different places if I allow this air to move into those spaces, most namely that exterior wall cavity, right? So this really drives me home to my final point. If this slide is the first time that you've looked at a psychrometric chart, I've got a lifelong homework assignment for you. Start looking at a psychrometric chart on a regular basis. If water damage mitigation and the technical aspects and secrets behind it are something that are important to you and the role that you play in your business, a psychrometric chart should be something at your fingertips at your desk. Even if it's just something that you just look at occasionally, throw a couple of readings on just from what's going on inside the office, just to refresh in your own mind the psychrometric relationships. Psychrometry is it's like a muscle. And the first time that you use a chart or play with a chart, that muscle's going to hurt. It's kind of like going to the gym, right? For anybody who goes to the gym on a regular basis, I'm sure you can sympathize. Me, I've gone to the gym, so I can really sympathize because I don't go often enough to make the pain worth it. But the same thing with a psychrometric chart. When you use a psychrometric chart, it's going to make the brain hurt. But if you keep doing it, that pain's worth something. It's going to do something for you. It's going to make the muscle stronger. And the same with a psychrometric chart. You've got to use the chart regularly in order to truly understand psychrometry. And for this example, what I want to call out is this is what's happening in the small inset image. 80 degrees Fahrenheit and 40% relative humidity are plotted on this chart. I've got a straight line going across the chart to show me how much water is in that air. That's why I've shaded the bottom half of the chart. That's all water that is in the air. And that's what the chart is calculated. That's approximately 60 grains per pound if you look over on the right-hand side. It has a dew point temperature of about 54 degrees. It has a vapor pressure of about 0.42 inches of mercury, somewhere in that ballpark. Okay, horseshoes and hand grenades, right? So when you look towards the left-hand side, here's where we start to understand the psychrometric relationship. As that line moves to the left, that line's not going to go up or down unless the amount of water in the air changes. We've got 60-ish grains per pound. That's going to remain the same unless you dehumidify it or humidify it. As you move to the left-hand side of the chart, the relative humidity is increasing. Take a look at 70 degrees at the bottom of the chart and move up to that same dotted line. You'll see the relative humidity is like, I don't know, 58. We were at 40. Move down to 60 degrees. The relative humidity becomes like 80. Move down to 54 degrees and the relative humidity becomes 100%. That's why the dew point is 54 degrees. Now, if I continue to move, the line goes off the chart. In other words, when I get below 54 degrees, there is no longer enough energy to support that amount of moisture in the air. It can't support it. That moisture is going to condense onto anything that's taking the energy away from it, right? Whatever that catalyst is. So it's going to condense. This is also, by the way, if you go back and review the episode we did on dew point, we talked about how if being below dew point creates condensation, being above dew point creates evaporation. The further you are below dew point, the more condensation you get. The further you are above dew point, the more evaporation you get. And this was the basis behind being 20 degrees above dew point with your building materials. I'm not going to go into the depth and detail of explaining that here because we've got a great video on it, but it is my invitation. If that sounds interesting to you, but it's not something you fully understand, go back and watch the Technically Speaking episode on dew point. Okay. And with that, that wraps us up on our best kept secrets. So just a quick recap on the secrets here. Measure twice, right? It's not about a single point in measurement. You're going to pull your hair out if you try to understand a single data point. It's about measuring twice. The surface matters. That's where drying actually happens. If you've never used the hygrometer near the drying surface, you're missing out, right? Understand what's happening at the surface. Remember, we solve problems, not symptoms. The 5 whys. Ask yourself why multiple times to really drill down to the root of the problem. Believe it or not, it's a great tool for more than just water damage mitigation. Just about any problem you're trying to solve, ask yourself why until you get to the point where there is no further that you can dig and you really get to the root of the problem. Remember, inspection and monitoring are not the same, right? Inspection is detail, lots and lots of detail. Document not only what was wet, but what isn't wet, right? Lots of detail. Versus monitoring is consistency. A key skill to focus on in your business as a whole with your entire technical staff is getting that consistency. You don't know if buildings are drying unless every technician in your business that touches that job monitors the same way. Think about how scary that is for a second. You don't know that that job is drying unless we're monitoring in the same way. That's scary. That's really scary. Remember that humidity, airflow, and temperature as a priority change over time, right? It's not the same job on day 2. In fact, I'd argue if it is the same job on day 2, you've got problems, right? Big problems. Specialty systems, your drying chamber doesn't end at the wall that you see. It ends where migration ends, all right? And specialty systems are what bring the cavities into your drying chamber. So you can mix that with the rest of your airstream. And last but not least, use the chart, right? Use the chart, practice the chart, understand the science that is restorative drying. So with that, folks, that wraps us up on episode number 12. Super excited about that episode today. Hopefully you were too. I'm going to talk a little bit about a couple of things that are kind of coming up into next year as we wrap up here, and then we're going to get into the Q&A. So first, just a reminder, my name is Brandon Burton. I am needing to correct my title on this slide. I am the industry relations sorry about that. But I'm the principal for industry relations here at CoreLogic and the chair of the ANSI IICRC standards. Quick invitation, by the way, for anybody, you'll see my email on the next couple of slides here. If you're interested in getting involved in industry standards, please reach out to me. We're about ready to relaunch the S500 revision process. It's about a 3 or 4 year time commitment as a volunteer to serve on that committee. But if you're interested, if you've got a passion for this industry and where it's headed, and even not just in water damage, but also in fire and smoke, in cleaning, in remediation, reach out to me and let me know that you're interested. I'd love to get you plugged in to volunteer, especially those that have been on this with me all year long. I can tell you've got a passion for this industry. So kind of give back into that passion and volunteer on standards. It's a very, very rewarding process. So with that, let's wrap up and take a look at what's coming next. So in season 2, super excited. We're going to branch out from water damage mitigation and get into commercial water damage, CAT response. We're going to get into fire damage restoration. We're going to get into remediation. And you're not just going to hear from me. I've got a number of industry friends, the experts that I go to when somebody asks me something other than water, because that's all I really know. And I'm going to go do basically some interview and some fireside chats with some of the best known names in these other areas of restoration in season 2. So look forward to that. You'll see an announcement with a schedule once I get everything all lined up. But some of the folks that I really trust and respect most in this industry will be joining me in Technically Speaking in 2023. So super excited to have you join us. Of course, we'll have a few water damage mitigation sessions next year as well that I will host directly, especially on some of the topics that I've alluded to. Another quick reminder for everybody, if you have not already looked at some of the past episodes, you can go to nextgearsolutions.com/webinars, and we have a number of restoration webinars there. In particular, we have all of the Technically Speaking episodes. They're cataloged for you. So if you missed any of the episodes in 2022, feel free to jump on to the Next Gear Solutions website and catch all of those. And then finally, last but not least, if you haven't already signed up to join us at Interconnect in Los Angeles, California in January, the 17th through the 20th of next year, please sign up. We're filling up fast. We have a dedicated track for every role in your business, from finance to general management to business ownership to water mitigation management to technician. We have a role for everybody in your business here, even reconstruction. So we have a track for each person or each role, and then a general session that will apply to the entire business, and a tie together that brings all the concepts for every role in your business together at the end of the session, so you all have a roadmap for where to focus as you move into 2023. So don't miss it. Interconnect 2023 in Los Angeles, California.